So today we will be doing sorting algorithms. And for sorting algorithms is sorting an arrays, that you have an array, say integer array of 5 elements. We want the elements to be in ascending order of their value. Fine. For that, in literature, we are proposed 3. We have many other sorting algorithms, but for your course, we'll be studying these 3, the 3 very basics one. Fine. One is bubble sort, selection sort, and insertion sort. Fine. So we'll be studying these 3 algorithms: bubble sort, selection sort, and insertion sort. Let's go one by one. Let's start with bubble sort. Look here. Initially, look here, you have an array. See, initially this is your array. Fine. You have an integer array of 5 elements. Fine. And the initial value of each element of array is like this. Like element at index 0 is 10. Element at index 1 is 40. At index 2 is 2. So on and so forth. Fine. So you have an integer array of size 5. So indexing will range from 0 to 4. Fine. So 5 elements are indexed from 0 to 4, and respectively elements are 10, 40, 2, 3, and 5. Simple. Okay. Now, how bubble sort works, that we will study in this. Bubble sort works, see, for this bubble sort, if you have an array of size 5, then for bubble sort, you will have 4 passes. We can call it a pass. I'll tell you what basically a pass is. Whatever is the size of array, that minus 1 will be the number of passes for bubble sort. Fine. Like in this particular example, we have an array of size 5, so we will have 4 passes. Is that okay? Fine. Now, what we will do next is, like in the first pass. In the first pass, we'll compare the first element with the second element. Fine. Or you can say we'll compare the element at 0th index to element at first index. If this is, you do a comparison like less than. If this value is less than this value, if it would have been true, we would have swapped it. Sorry, if it is less than this value, fine, we'll do nothing. But if it would have been greater than, then we swap the values. Swap, you understand? Swap is just change the value places. Put 40 there and 10 there. If it would have been greater, then we will swap. If it is already less than this value, we do nothing. We just go on to next passing. Fine. So simply, first thing we did is we compared this element at index 0 to element at index 1. And if it is less than this, element at index 0 is less than element at index 1, that is fine. We'll do nothing. Fine. If it would have been greater, we would have swapped the values. Fine. Next we will do is we'll compare element at index 1 to element at index 2. Fine. Again, we'll see if it is less than or greater than. If it would, as this is 40 is greater than 2, so we are falling in this case. So we will swap the values. Now we will put 2 here and 40 here. Is that simple? Is that simple? Okay, fine. Next, we will compare element at index 2 to element at index 4. Sorry, index 3. Again, we'll see whether 40 is less than 3. If it would have been less than 3, we would have just moved next, but it is not so. 40 is greater than 3. So again, we are in the swap position. So we will swap is put 3 here and 40 here. Fine. Fine. Again, next we'll repeat the same logic. We'll compare value at index 3 to value at index 4. We'll see 40 is greater than 4. Again, greater than. So it is at swap position. So we'll put 4 here and 40 here. Fine. Fine. Then we have already reached the last element. No more element is left to compare. So that is, at this point, we complete your pass 1. Pass 1 is completed. Right? So you will see after pass 1, after pass 1 on this array, the elements, some elements have changed their place, and now the elements are like this: 10 here, 2 here, 3 here, 4 here, and 40 here. Fine. Fine. So after pass 1, you will have elements at these respective positions. Correct? Fine. And what is the significance of pass 1? In bubble sort, what we are studying here, in bubble sort, after pass 1, the largest element will be at the last index value of that array. That means whatever has been the largest element in this array, that would have taken its final position, and the final position is at the last index value of the array here. So we have this to be final sorted. We know this is the final position for value 40 in the array. Fine? Fine? To make array sorted, 40 will be finally at this position only. It won't be changing position. Is that simple? Fine? Okay. Now, that means after pass 1, you can also understand it this way, that after pass 1, only the largest element is placed at its place, and the remaining elements we need to follow the same process as we followed in pass 1. Fine? So let's repeat the process, that we will again start, compare the element at index 0 and element at index 1. 10 is less than 2? No, 10 is greater than 2. So we will swap their value. Fine. Again, we'll compare value at index 1 to value at index 2. 10 is greater than 3. Sorry, less than 3. Agar hum bole, no, it is greater than 3. So greater than case mein we will swap. So we'll put 3 here and 10 here. Is that simple? Fine. Again, we will compare value at index 2 to value at index 3. 10 is greater than 4. Yes. So again the swap position. It is greater. So we will again swap the values. And we will just end here. In pass second, now we are going through pass second things. In pass second, we will end up here. We won't be comparing this element because we know after pass 1, the last element is already added, already sorted, and it's at its final place. Fine. So in pass 2, we will go only to this value, that is size of array to -1, less size. Fine. So after pass 2, we'll be having elements 2 here, 3 here, 4 here, 10 here, and 40 was already here. So after pass 2, this is the results after pass 2. Right? So after pass 2, you will say after pass 2, last 2 elements, that is the largest was at its last index after pass 1, and second largest element will be at second last index in the array, that is 10 in this case. So we have these 2 elements. After pass 2, we'll have largest 2 elements at their final position. Right? So we need to sort only the remaining array, that is this part. Right? That is just by chance happened in this case, in this example, that all these 3 are sorted. However, it's not necessary that all these 3 are sorted. After pass 2, only last 2 elements will be at their final position. Right? You need to sort other elements. So in pass 3, what will we go for next? Pass 3. In pass 3, we'll again follow the same procedure for these 3 elements, right? That is compare 2 with 3. 2 is less than 3. So we do nothing, no swapping. We'll compare 3 with 4. Index value 1 to 2. That is, we'll compare 3 with 4. 3 is less than 4. Fine, we'll do nothing. So we'll end up, pass 3 will end up with this array result. Fine. And we'll say after pass 3, these 3 elements are sorted, and you just need to follow these 4. Right? So we will go with pass 4. In pass 4, we'll just compare these 2 elements. And if 2 is less than 3, so we will do nothing. And that's final. That we will say now this to be the largest element in this remaining array is at its final position here. So we'll have these elements sorted after pass 4. Right? If I say that we have an array in which 5 elements are there, and after pass 4 elements are placed at their final position. The 5th element is placed by default at its final position. So by default 2 is at its final position, and you will have a sorted array. Simple? Is this simple? Is this simple, everyone? Fine. I'm just repeating the process quickly in one go. What we are doing is we are using bubble sort. The objective of bubble sort is if you have an array of 5 integer elements, like in this example, at the output we want those elements to be in ascending order. That is all. Right. So initially we have an array, this elements. Fine. What do we do? We'll compare pairwise. From the first element we'll start and we'll compare that element to the next element and see if that is less than or greater than. If it is less than, we'll do nothing and go on next comparison. Fine. But if it would have been greater than, we just swap the values. You just need to keep this in mind. Fine. And then we'll compare second and third element, follow the same logic. Then compare third and fourth, then compare fourth and fifth. That's it. You have compared all the elements, so we'll stop. So that is pass 1. And after pass 1, we will say you will have largest element of this array at its final position. Like in this case, 40 is the largest value in these elements, all these values. So 40 will be at the last index value in the array. That is simple. Fine. Then we'll compare. We will start with pass second. Fine. In pass second, again we'll compare first element with second, second with third, third with fourth, following the same logic. If first is less than second, then nothing we will do. But if it would have been greater than first value at first index will be greater than value at second index value, we would have swapped the value, just following the same logic. Then after second pass, we will have 2 largest elements at their final position, like 10 and 40 in this case, and the remaining you need to sort. Right? So on and so forth, we'll keep on going. So you'll see after pass 1, you will see after pass 1, 1 element was sorted. After pass 2, 2 elements were sorted. After pass 3, 3 elements were sorted. After pass 4, 4 elements were sorted. And we say that is final because once in an array size of 5, array of 5 elements, if 4 elements are sorted at their final position, the 5th element is by default at its final position. So you have a sorted array like this. Fine. That is okay. That's simple. Fine. Okay. This is called bubble sort, and number of passes will be size of array minus 1. Whatever the size of array you have, minus 1 will be the number of passes. Fine. That's simple. Now just quickly give yourself a 2-minute try to code this logic. Just code this logic. I'm giving you a hint that you have to use nested loop in this. Why nested loop? Because you will be following 2 things. One outer loop will be for number of passes, and inner loop you will be doing for this logic what we are doing, comparing this element with this one, comparing this element with this one, so on and so forth. So you will be using nested loops for this, in which outer loop will be for number of passes and inner loop will be for logic, what you are following, comparing respective index values. Right? Passed an array of 5 integer elements, the same we took for the example. Fine. Then we have created 3 integer variables, ij and temp. Right? Ij, again, as we did, this is your outer loop, your inner loop. And as we discussed, outer loop we will be coding for number of passes. Fine. So like when your size of array S is 5, so the number of passes we want is 4. Fine. So this way we have coded it, I equal to 0 to I less than equal to s minus 1. Or same you can write it, I starting, if you want to start it from 1, I equal to 1 to I less than s. Fine. So it will automatically go s minus 1 times. That is what we want. So you can code it this way or code it this way. Is that okay? Fine. So you write this condition, initialization and condition, or you write this initialization and this stopping condition of getting into the outer loop. Why we have kept this? Because we want s minus 1 passes. Fine. Because s is the size of array and we want s minus 1 passes. So accordingly, put the condition for outer loop. Fine. Then we go to the inner loop code. In inner loop, what do we want? We want, like in the very first pass, we want to compare from index 1, we want the index values to go from 0 to 3. Why 3? Because, go to the example, because you will just go to this pass value and compare it to its next value. That's it. Fine. Same way, we want it in code to be like this. We want it to be code to be like this, that in pass 1, the index value we want to assign to element j is 0 to 3. In pass 2, we want to assign those values from 0 to 2. Right? In pass 3, we want to assign it to 0 to 1. And in pass 4, we just want it to assign to 0 to 0. Yeah, that means we only want to execute in pass 4 only once we want to execute the loop, right? So accordingly, we start the index, initialize the inner loop j with 0, and the stopping condition for this loop to be when j is less than s minus 1, that is the size minus 1, 4, and minus I. Fine. Fine. So 4 minus 1. Is that okay? Is that okay? Okay. Actually, yes. Because see, if you see this one, it will be 4. When I is 0, it will be 4. Less than 4 means it will go up to 3. Less than 4 means it will go up to value 3. As the value will be 4, this condition will be false and it will stop. Right? So you need to understand putting the values of these outer loop and inner loop. The key is outer loop will specify the number of passes. Inner loop will specify the logic index values you are going in the logic. Right? And in the inner loop, you will check the logic. Logic was, we will comparing value at index 0 to index 1. So you are comparing ij to ij plus 1. Again, we were checking if it is greater or less than. If it is less than, we were doing nothing. But if it was greater, we were swapping the position, swapping the values. Right? Swapping is just changing the values. This is just the code for swapping the values. Fine. So just swap the respective values. Fine. So on so forth. Just keep on doing these logic for these index values, and for how many passes, this outer loop will tell you for how many passes. Is that simple? Is that simple? Anybody has tried any other logic of this? Anybody has tried any other logic? No? All good with this? So this will be the bubble sort. Simple? And that is how we coded the bubble sort, right? And this is just simply like complete program, header file, format, function prototype declaration, your main function in which you declared an array, function calling statement for this function in which you are passing the array and the size of array, right? Once changes will be done, your array will be sorted, and after this, you will be just printing your sort For this loop, using this loop, you are just printing your sorted array. Fine. So after this loop, it will print your array to be 2, 3, 4, 10, and 40. And you can see it is sorted now. Simple to everyone? Fine? Fine? No question in this? Simple, eh? So let's move to next sorting technique. That is called selection sort. That's simple, fine. Let's move to next sorting technique. That is called selection sort. It will also do the same thing. Result, output your array to be sorted. Fine. So this is selection sort. Now, again, we will have number of passes in selection sort. The similar way as in bubble sort, as well as number of passes will be same. Number of passes will be your size of array. That is number of elements of in array minus 1. Like in this case, we have again we have an array of 5 elements. So number of passes will be 4. Fine. So that will be the number of passes. Okay. Fine. Now in every pass in bubble sort we are comparing pairwise. Here too we'll do some comparison, but how we are doing so we'll discuss that. Okay. Okay. So let's start. Initially this is our array, right? Elements at respective places. Fine. So in first pass we will compare element at index 0 to element at index 1 with the same logic. If it is less than this element, we'll do nothing. But if it is greater than, so we will swap the value at their respective places. Fine? Fine? We will swap the value at respective places. So 10 is less than 40, so we do nothing. Then we do is compare the element at this 0th index itself to next index element. That is 0 to 0th index to second index. That is 10 is less than 2. No, it is greater. So we will swap it. We'll place 2 here and 10 here. Simple. Then next we will do is compare this element to the next index value. That is this element. Right? 2 is less than 3. Yes. So we'll do nothing. Again, we'll compare this element to the next index value, to the last index value. 2 is less than 4. Yes. So we'll do nothing. Right? So that is end of pass 1. That is end of pass 1. So in pass 1, what we did, we first picked the element at 0th index and compared it with element at first index with the same logic. If it is less than, we'll do nothing. If it is greater, we'll swap the values. After that, same element at 0th index, we compared with element at index 2, so on and so forth, unless we reach the last index element of the array. Simple? Is that simple? Fine. So after pass 1, that is how values are changed. 2 is here now. And instead of 2, 10 is here. Rest elements haven't changed their positions. Right? Fine. Now, logically, after pass 1, in selection sort, what happens is the smallest element of the array is at index 0. After pass 1, the smallest element of the array is at index 0. Fine. So that is how the selection sort works. Fine. Then you are asked to sort these remaining elements using the same logic. Fine. So we'll start with pass 2. And in pass 2, we'll start with this element. That is element at index 1. And we'll follow the same logic. So we'll compare 40 to 10. 40 is less than 10? No. So we will swap the values. Again, we'll compare element at index this, which is 10 now, 10 to element at next index, that is 3. 10 is less than 3? No. Again is false. So we'll place 10 here and 3 here. Swap the values. Again, we'll compare this value to the next index value, that is here. Fine. So 3 is less than 4? Yes, it is. So we'll do nothing. And we have already reached the last index, last index of the array. So we'll stop. That will be the end of pass second. Right? So end of pass second, after the pass second, this is the elements are now. See, 3 is here, 40 is here, 10 is here, and 4 is here. Fine? Fine? So after pass second, we will say the first two smallest elements are at their sorted place. That means the smallest element was after pass 1 was at index 0, and the second smallest element in the array after pass second would be at index 1. That would be the result of pass second. Right? Then in pass 3, we will repeat the same process with the remaining elements. Right? So in pass 3, we will start with element at this index. We'll start with element at index 2 and compare 40 to 10. Again, 40 is less than 10? No. So we will swap their values, 10 and 40. Right? Then again, we'll compare value 10 to next index value, that is 4. 10 is less than 4? No. So again, this is 4, this is 10. Swap the values. Right? So after pass 3, that is the changes will be reflected. 4 is here now, 40 is here, and 10 is here. Fine? And we'll say after pass 3, first third smallest element will be at index 2. Or we can say third smallest element in the array will be the third element of the array. Fine? So we'll be left with just sorting these two elements. So in pass 4, we will start with this element. That is at index 3 we will start and compare it with the next element. If 40 is less than 10, no. So we will swap the elements. That is simple. Right? So after pass 4, we'll say the fourth smallest element of the array will be the fourth element of the array, or we will say the fourth at the third index in the array at this final position. Right? And these were already at their final position. So after pass 4, these all are sorted. So this one is sorted by default. So you have a sorted array. Is this simple? Is this simple? The number of passes decided is same as in the bubble sort. That will be whatever the size of your array is, number of elements in the array minus 1. So in this case, 5 is the size of array. Not in bytes, we are talking about in number of elements, right? So 4 we have, because 5 elements we have, minus 1 would be 4. So we'll have 4 passes for this, sorting this array. Right? And in the first pass, we compared element at 0th index to element at first index, keeping the same logic. If it would have been less than, we do nothing. If it would have been greater than, we would have swapped these values. Then compare it to value at index 2, then compare it to value at index 3, then compare it to value at index 4. Right? So after pass 1, you will have the smallest element placed at its final position. After pass 2, you will have second smallest element placed at its final position, and for after pass 1 it was already, so you have 2 smallest elements at their final position. After pass 3, you will have third smallest at its final position, they were already at their final position, so you will have 3 elements sorted. After pass 4, you will have 4th smallest element at its final position, so you will have first 4 elements of the array final sorted. 5th will be by default at its place, so it is sorted. That's simple. Again, give yourself 2-minute try, code this logic. It's very much same as bubble sort. You just need to use like different logic. Same, outer loop will be for number of passes. Inner loop will be for logic.